In this accelerated math goal, we are given a geometric shape. We've got a hexagon here. It has 6 sides and a circle inside of it. And when you do that, where it's touching the outside, that's called a circle inscribed in a hexagon. And our job is to find the area of the shaded region. So we're going to find the area of this shaded region. So let's go about getting that done. Right here we have this original problem. And what I've jotted down for you is the formulas for the area of the two shapes. In this case, we have a circle with a radius of 5 inches and a center point T. The formula for the area of a circle is pi r squared. And then around that, we have the hexagon. And the formula for the area of the hexagon is right here. And in order to find the area of the shaded region, we're going to have to find the area of the hexagon and then the area of the circle. And then we're going to subtract the two because we want only the outside area. So find the area of the hexagon, find the area of the circle, and then subtract the circle from the hexagon. So let's get started. The first thing we'll do is find the area of the circle, right? And we know that the area of a circle is pi r squared because pi are not circular, pi are squared. So we'll find that. We'll begin by marking down pi here times the radius, which is 5. So we'll put that in parentheses, squared. And we know that 5 squared is 25, so we can write that temporarily as 25 pi. That is the area of the circle. That's all of the space inside of here. Then we'll find the area of the hexagon. Now the area of the hexagon is 2 times the square root of 3 times a squared. And the a stands for the word apothem. Now you don't have to know or remember that, but it's the word apothem. And the apothem is the line that's drawn from the center to the midpoint here of one of the sides. From the center of the hexagon to the midpoint of its sides, called the apothem. And we square that. So in our case, it turns out that that is also the radius of our circle. So what we are going to do is, in place of a, we're going to plug in the value of our radius up here, 5 inches. So 5, we're going to square that, and we're going to multiply that by 2 times the square root of 3. Now 5 squared is 25. And we're going to multiply that by 2 times the square root of 3. But because of the commutative and associative properties, we can group these guys, rearrange them however we need to because it's multiplication. And we'll multiply 2 times 25, which gives us 50. 50 times the square root of 3. And that is the best way to write our area of our hexagon for now. And what we need to do is then subtract those two values. So, and that's not a negative, by the way, that's a star, so we'll star both of those. And what we'll do is we'll take 50 square root of 3, and from that we will subtract 25 pi. You can punch that in your calculator. It's going to give you 86.6. 86.6 rounded, so approximately that. That's approximately that value. And then we're told to use 3.14 for our value of pi, so when we multiply 25 times 3.14, we're going to get 78.5. 78.5. And then we're asked to subtract those because we want to find the area of the outside. That gives you 8.1. 8.1 inches squared is the area of this shaded region all the way around there. And we're done.